last homework, and we are going to continue with some important parameters in motion. Today we're going to talk about acceleration, and you have used this term, I'm sure, but we're going to see what it means physically, and it is the speed of the speed. So what we mean by that is that this is the variation of the speed divided over time. Remember, I hope you remember that the speed was we define it like the distance traveled in the time required. So here we're going to have also the division of something, but here instead of the variation of the position, which is the distance traveled, we are going to have the variation of the speed. That's why we say it is the speed of the speed, because it's the same formula, except that here instead of xf minus xi, we have vf minus vi. So final velocity, final speed, minus initial speed, initial velocity, that's the v, over time. That's the formula we're going to use. And of course, if we do the calculations, then we know that the speed or velocity is given in meters per second in the international system, and if you subtract, it's going to have the same unit, because you subtract meters per second minus meters per second, the result is meters per second. If we subtract this and time is in seconds, if we do these calculations, we have meters per square second. So that's the unit, meters per square second. In the international system, of course, you can have it in any other unit, like kilometers per square hour, but you know how to do the transformation of units. So we are going to talk about the meaning, not about conversion, because you know that already from other videos. It's important to know that this magnitude, which is also a vectorial magnitude, and I didn't put it here, but it's a vectorial magnitude also, in the sense that it needs an arrow to be described. But we're not going to talk about that, but we are going to see that this magnitude has a sign, because it's going to depend on the velocities, and it can be, so the acceleration can be positive, sorry, it can be negative, or it can be zero, and we're going to study these cases. For example, if we have a positive acceleration, that means that the acceleration is larger than zero. What does it mean? So if we remember the formula, here we know time cannot be negative, so positive, it's always going to be positive. So the only difference is going to come from the velocities. So if a is positive, it means that the difference in velocities is also positive. It's bigger than zero. And that means that this velocity is bigger than this one, because if we subtract something, so if we do this calculation and this has to be positive, it means that the first term has to be greater. So that's what it means. The final velocity is greater than the initial velocity. That's why when you subtract them, you have a number larger than zero. Again, so the final speed is greater than the initial speed. That's what it means. And so the meaning of this, okay, you say this is the formula, yes, but what it means is that we start with a velocity, with a speed, and it's going to be greater and greater. So it's going to increase. The speed is increasing, is becoming bigger every time. In everyday language, it's accelerating. So when we have a positive acceleration, what is happening is that the object is accelerating. For example, in car advertisements, we hear, this car goes from 0 to 100 kilometers per hour in 5 seconds. That's exactly the meaning of acceleration in our everyday language. But in the scientific way of saying it, is acceleration is larger or is greater than zero. Another case, if it's lower than 0, what does it mean? It means that the subtraction that we talked about is lower than 0, so that the final velocity is less than the initial velocity. So the final speed is less than the initial speed. That's why when we do this calculation, this is bigger, so in the end we're going to have the total calculation is going to be negative. And if the initial velocity is bigger than the final one, it means that we are losing velocity, we are losing speed. So the speed is decreasing because the final one is less than the initial one, so it's decreasing. In everyday language, it's breaking, so it's stopping, okay? It's breaking. If the sign of the acceleration, if the acceleration is 0, what does it mean? It means that the final velocity is equals the initial velocity. The final speed is the same as the initial speed. It means it doesn't change, it's always the same. The initial speed is the same as the final one, so the speed is constant, it's not changing, and that's called a uniform motion. Here we also have, so uniform motion is that you're always moving at the same rate, at the same speed. And here we have also the case where the velocity is 0, and it's also included here. So it can also be that it's not moving at all, and it has 0 velocity, and it's not changing. So it's stopped. But stopped is a particular case of uniform motion, because the velocity is 0 and not changing. So if the velocity is 0, it means it's not moving, and if it doesn't change, it means that it doesn't have acceleration because it's not changing this speed. But in general, it can be a number like 1 meter per second, or whatever number you want to give to the velocity or the speed, and it's not going to change. That's what this means. Let's see some examples. A problem, like the ones you're going to have in your exercises. I'm going to see 3 problems here. The first one, the time a vehicle takes to go from 0 to 100 kilometers per hour is one of its selling points, as I told you before. If a motorcycle does it in 3.4 seconds, what is its acceleration? So let's see the data. We have the initial speed is 0 kilometers per hour, the final speed is 100 kilometers per hour, and the time required to go from 0 to 100 is 3.4 seconds. That's the data. And first we're going to express everything in the same units, because we have kilometers per hour and we have seconds. So we're going to choose to change it to the international system, because that's you could change it also the seconds to hours and have it in the same units, but I'm choosing, because I know how to do this maybe more easily, I'm going to change kilometers per hour to meters per second. So this is the first one. 0 is 0 in any unit, so I will show you how to do it later on, but in this example I chose not to do this calculation. So I'm only doing the one for the final speed, and that's 100 kilometers. Then I have to multiply by this factor, that is that 1 kilometer is 1000 meters, and then 1 hour is 3600 seconds. And if I do the calculations, I have that 100 kilometers per hour is 27.78 meters per second. And I have the time already in seconds, so I'm not going to touch that. Then the formula I'm going to use is the one for the acceleration, the one we saw, and that's it. Then I just need to put the data here, so the final velocity or the final speed is 27.78 minus the initial one, that is 0, divided over this time, and that gives us 8.17 meters per square second. And I want you to write the meaning. That means that the speed increases 8.17 meters per second every second. That's why we have square seconds, because it's 8.17 meters per second. That's the velocity every second. So two times the seconds. Okay, so here's the summary. That's what you have in your student PDF. And let's see another example. A car is driving at 72 kilometers per hour when the driver sees an obstacle in the road. The driver brakes such that in 2 seconds she reaches 36 kilometers per hour. So from 72 to 36, she's braking, of course. Calculate the acceleration in SI units. Again, the same. So we have the data. We have the initial speed, 72 kilometers per hour, the final speed, that's 36 kilometers per hour, and the time required is 2 seconds. So we transform everything into the international system units. So 72. I'm not going to explain this any longer because you have the whole video of conversion factors and you can watch it over and over again. But 72 kilometers per hour is 20 meters per second, and 36 kilometers per hour is 10 meters per second. And the time is already in seconds, so I don't need to convert it. Remember, I can use any unit I want. I can transform it to hours, this one to hours if I want. But it's good to have everything in the international system. Not necessary. What is necessary is to have the same units. You cannot have hours and seconds. You need to have hours and hours or seconds and seconds, but nothing like mixed. But you can choose if you wanted to do it in kilometers per hour and then hours. It's okay. It's okay. I just like more the international system because it's the official one. Then the formula, again, the acceleration formula. And we just put the data in, and that's the final speed, that's 20, final speed is 10, initial speed is 20, and then the time required is 2, so I have that this is minus 5 meters per square second. And that means that the speed decreases because it has a minus, and we know it's braking. But the minus here, it means it's not wrong. It means, as we saw, that the object is braking. So the speed decreases 5 meters every second. I'm going to remove the minus here because in the minimum we don't need it. Because when we say decreases, that's where we mean this minus. And yeah, so this is the one with all the colors that you have in your student PDF. And I'm going to show you the last problem. This is a graph. So use the graph to calculate the acceleration for each segment. Here you have the velocity and the time. So we are seeing that the velocity is changing in these parts. We have part 1, part 2, and part 3. And we need to calculate the acceleration in every segment, okay? In segment 1, segment 2, and segment 3. So how are we going to do it? First, we're going to check that everything is in the same units, so that I don't have to convert, and I have meters per second and seconds. So I'm not going to be bothered with units because I have seconds and seconds, no problem. Then, in the first segment, I have that the initial velocity is 15 meters per second, and the final one is the same because it hasn't changed. It's also 15 meters per second. And the time I have required to go from the initial speed to the final speed is 40 seconds. So I have everything I need. Then I have my formula. I put the data in, so 15 minus 15 over 40, and that is 0 meters per second. So what I know is that when I have the acceleration is 0, what I have is on a horizontal line. Because when I have constant speed, of course the speed doesn't change, and and that means I'm going to have the same, so it's not going to go up because it's not going to increase, or it's not going to go down. It's going to have the same slope. So horizontal line, okay, A equals 0. Let's see the second segment. Here we have the initial velocity is 15 and the final velocity is 45 meters per second. And here, this is the time required from 40 to 60, that's 20 seconds. So I do the calculation, 60 minus 40 is 20 seconds, that's the time required. If I do the calculations with my formula, I put in the final speed minus the initial speed over 20, that is the time required, that's 1.5 meters per square second. And so here we see that the acceleration is positive when I have an increasing slope. And what it means here, again, this number, what it means is that it's increasing 1.5 meters per second every second. So every second we have a velocity that is bigger by 1.5 meters per second. Finally, in the third part, the third segment, I have the initial speed, that's 45 meters per second, and the final speed is 0. Okay, I have ended up in 0. And the time is this time. So from 60 to 100, that's 40. I do the calculation saying, okay, 100 minus 60, that's 40 seconds. And if I put it in the formula, then I know the final one is 0 minus the initial. That is 45 over 60, that's minus 1.125 meters per square second. And so here I have an acceleration that is negative, and I can see in the graph that when it's negative, then I have a decreasing slope, so it's going down, okay? And again, just to remember it, when I have the negative, it means that it's braking, of course, because we're going from 45 meters per second to be totally stopped, 0 meters per second. So it's braking, and it's decreasing 1.125 meters per second every second. That's the meaning of it. And here you have the problem with all the colors, and these are the new exercises you need to do. So here it is. See you in the next video.